Hello everyone, welcome to lesson 5-6 part 3. Today we're going to be focusing on simplifying radicals using division. And this actually is just going to combine everything that we've learned about radicals, but we're going to do a lot of simplifying with the coefficients and the radicals. So to get us started, I have up at the top of your notes 2 examples. Whenever you see a division problem like this, and you are able to evenly divide out the numerator and the denominator, then you can just, it's the same as putting them both under one radical, the numerator and the denominator under one full radical. We see here that 18 divided by 2 is 9, and the square root of 9 is 3. And this is pretty much what we're doing today. Another example is this one right here. We have 80 divided by 10. So they put it all under one radical, and you don't have to do it this way. You can simplify out your 80 and then simplify out your 10 if you can, and then simplify. But in this case, 80 divided by 10 is 8, and the square root of 8 is 2 to the square root of 2. Notice here that they pulled out a perfect square. Okay, your perfect squares are 4, 9, 16, 25, 36, 49, and so on. So you could always pull out those perfect squares and easily simplify or factor out the radical that way also. Okay, so let's look at our steps. Step 1, simplify the fraction that is inside the radical if you can. So for example, if you look at number 1 here, I can simplify the fraction. The fraction 32 divided by 8 is 4. So it's the square root of 4. And then if you can't simplify the fraction from step 1, you'll rewrite your fraction with the numerator and the denominator under its own radical symbol. So if you can't simplify it, you'll write it like this, with the numerator under its own radical and the denominator under its own radical. In the case of example number 1, though, we were able to simplify it, so that works out. Simplify or factor the numerator using perfect squares or a factor tree, and then step 4 is the same thing, but for the denominator. In this case, we got rid of the fraction, so we can just, the square root of 4 is 2, and how do I know that? Because 2 times 2 is 4, and we are looking for groups of 2. Now, a lot of you are getting confused with the index on your work, so I'm going to show you something really quick. If you have 2, and there's a 4 right here, and there's a 32 on the inside. This 4 is not an exponent to the 2. This 4 is the index that belongs to the square root and tells you how many numbers will be in each group. So when I factor this out, and we've done 32 so many times, you guys should probably have it memorized that 32 factors out into 5 2s. This 4 right here tells us we are going to circle a group of 4. That means I'm going to circle a group of 4 2s right here, and I will have 1 2 left over. This group of 2s, you pull that out and you multiply it by the 2 on the outside. We're left over with a 2. So inside the square root, we have a 2 left, and we end up with 4. And then 2 to the root of 4. Now remember, this 4 is not an exponent, it is an index to your radical. All right, so moving on to practice number 1. Step 1, can we simplify the fraction? And the answer is yes. 100 divided by 4 is 25. And then 25 breaks down into a group of 5s. Now, if we don't see an index here, then we assume that it is a 2. Okay. So the answer here is 5. All right, let's look at example number 2. In example number 2, we can't simplify the fraction that's inside. You don't really want to deal with decimals in this case. So we go to step 2. We're going to rewrite this as two separate, radicals, because if you notice, they're both perfect squares. Okay, so 64 and then over the square root of 49. Okay, now I know that 64 factors out to 8 times 8, and 49 factors out to 7 times 7. Now, a lot of you are going to want to continue to factor out your 8s because they're not prime numbers. But if you know that these are perfect squares, you don't have to continue factoring it out, because if you do, you're still going to come up with the square root of 64 being 8. If you need to continue to factor it out, though, you can. Okay, so that means the square root of 64 is 8, and the square root of 49 is 7, and that is my final answer. Yes, it's improper, so leave it improper, and do not turn this into a decimal. We're keeping them as fractions. Okay. Same type of problem for practice number 2. '81 can factor out. It is a perfect square, 9 times 9. And then 100 can factor out. It is also a perfect square, 10 times 10. And so your answer would be 9/10. Okay, and we're going to leave it like this. We can't simplify it. The only thing I would tell you with your fractions is to simplify them. But in both of these cases, we can't. Okay. All right, let's move to example 4. Okay, so this one right here, 52 is divisible by 2. So I'm going to go ahead and take 52 divided by 2. Okay, and I get the square root of 26. Okay, so now I'm going to see if I can factor 26 out any further. Okay, so when I factor 26, I get 2 and 13. Well, those are both prime numbers, so I can't go any further than this. This is my final answer. Okay. All right, let's look at this one. I do believe 72 is divisible by 3. So I'm going to go ahead and divide this. Okay, and all right, so 72 divided by 3 is 24. So you have the square root of 24. So now I'm going to see if I can factor out 24. Please make sure that you factor all the way. Some of you are leaving your answers like this. That's not the most simplified form. Okay, so 3 times 8 is 24, 2 times 4, and then 2 times 2. So I end up with 3. Okay, so I can, now since there's no index, I know that it's a 2. So I'm going to circle groups of 2. So I have one group of 2 2s. That is going to be pulled out or factored out of the radical. And I'm left with 2 times 3 on the inside. So my final answer is 2 square root of 6. So the only thing new really in these is the initial division part of the problem. Okay, and that's for the first page. Remember, it gets a little bit more tricky as we go. All right. Now, 8 and 50 can be simplified, but they cannot be divided to get an even number. So I'm going to show you how to do this problem in 2 ways, okay? The first way is just to go ahead and start factoring out your numerator and denominator. And so this ends up being square root of 8x cubed over square root of 50x. Okay, and so I'm going to factor these out. Okay, so we have 8, 2 times 4, and 2 times 2. Okay, so 2 times 2 times 2, and then I have 3 x's. Okay, and this is a square root, so I'm going to circle groups of 2. Okay, so when I pull that out, I have 2 times x on the outside and 2 times x on the inside. So the square root of 8x cubed is 2x square root of 2x. Okay. Now I have to factor out the 50. So down here, I'm going to factor out 50. 5 times 10, and then 5 times 2. So I have 2 times 5 times 5, and then we have an x. Don't forget the x. And I'm going to circle my groups of 2. So I have 2 5s that I can pull out. So I have 5 square root of 2 times x. So this one simplifies out to 5 square root of 2x. Okay. Now, we have a radical here in the denominator, and we can't have radicals in the denominator. But since both of our radicals are the same, the square root of 2x over the square root of 2x would be the same as like 3 over 3 or 17 million over 17 million. They all equal 1, right? So in this case, we can actually cancel these out because they total 1, so it'll just be 1 times the rest of it. And our final answer would be 2x over 5. Okay. Okay, that was way number 1. I'm going to show you another way to do this. Okay. And what we're going to do instead of factoring first and then simplifying is that we're going to simplify first. So in this case, we have 8x cubed over 50x. Well, my coefficients can simplify. So I can divide these both by 2. So instead of 8 over 50, I end up with 4 over 25. Okay. And then notice my x's. I have 3 x's up here and 1 x down here, which is the same as saying x cubed minus 1, right? X cubed minus the 1 that's right here, which equals x squared, okay? So that x squared stays on the top, okay? And now my bottom one does not have an x. And what we're going to do is we're going to take the square root of all that, okay? So we're going to take the square root of 4x squared over the square root of 25. And as you can see, the square root of 4 is 2. The square root of x squared is x, and we have 2x right here. And the square root of 25 is 5. Now, to me, simplifying first is easier because we have to do less factoring like we did over here. This is just a lot. They ended up being perfect squares right here. If you want me to show you here, 4x squared is 2 times 2 times x. So I would factor out a 2x. And then the square root of 25 is 5 times 5. And when we pull out our pairs, we end up with 5. Okay, so 2 ways to do the same problem, you get the same answer, whatever way works best for you. And whatever way really makes more sense to you. A lot of times the long way makes more sense to me. I like to see all the steps, but for some of you, I know that you don't like to do that. So either way. All right, so let's look at practice 5. I am going to simplify this before we do any factoring. So I am going to divide both of these by 3x cubed, okay? So 27 divided by 3 is 9. 12 divided by 3 is 4. And then we have x to the 5th minus x to the 3rd, which gives us x to the 2nd power. And if you've forgotten how to do this, you're going to want to go back to, I think, lesson 5-5 or 5-4, one of those, okay? So our x squared stays on top here. And so then I can factor these out. So 9 factors out to 3 times 3. 4 factors out to 2 times 2. So those are our 2 groups right here that we can pull out of each one of those. So this ends up being 3x over 2. Okay. All right. Let's move on to page 2. Okay. All right, we are going to learn something new. We're still going to follow the same steps of dividing and simplifying and all of that. But one thing that you have to know when we're dividing with radicals is that you cannot ever have a radical in the denominator. So that means that you have to get rid of it. So let's look up here at the note, and then I'm going to walk you through this example, and then we're going to try it. When dividing with radicals, it is important to note that you cannot have a radical in the denominator. If it does, you have to rationalize the denominator. That's what this whole step is called, okay? Basically, what does this mean? It means that you have to get rid of the radical in the denominator by multiplying the entire fraction. So, for example, here, right, we have square root of 7 over square root of 3. You're going to have to multiply this entire thing, okay, by another fraction that is equivalent to 1. So like 3 over 3, 2 over 2. In this case, the square root of 3 over the square root of 3. That equals 1. Just like our square root of 2x over square root of 2x on the previous page equaled 1, and we were just able to cancel them out. That's what you're supposed to do. And then this will help you to remove the denominator. So basically what you've done is you've taken the square root of 7 over the square root of 3, and you've multiplied it by this square root over the square root. Okay, that's 1. So we end up with the square root of 7 times the square root of 3 over the square root of 3 times the square root of 3. That gives you the square root of 21 over the square root of 9. And guess what? Your 9 factors out to a 3. So your numerator still is a square root. It still has a radical, and that's fine. Your numerators can have radicals. Your denominators cannot. So you will always have to rationalize the denominator if you have a square root there, okay? So let's go ahead and practice this with example number 6, and you're just going to follow each of these steps the way that I've shown you up here. So I'm going to change this to the square root of 15 over the square root of 2 because you can't divide those evenly. And I know that I can't factor these any further, so I need to get rid of my denominator by multiplying both the top and the bottom by this square root, because what's going to happen when I do that, it's going to get rid of it. Okay, so this equals the square root of 15 times 2 and the square root of 2 times 2. Okay, that gives us the square root of 30 over the square root of 4. Now, I can try to factor out 30, but I already know that 30 can't be factored out. You get 3, a 2, and a 5. There's no pairs that we can pull out. So the square root of 30 is going to stay like that. I do know that the square root of 4, though, is 2 times 2. So I end up with the square root of 30 over 2. Okay, and that would be my final answer for example 6. Okay. Okay. Moving on to example 6, very similar, except now you have an x, but you treat it as you would any other number. So I'm going to take the square root of 5 over the square root of x, and I'm going to rationalize the denominator. I can't factor those radicals out. So I'm going to multiply them both by the square root of x. So I end up with 5 times x and the square root of x times x, which gives me the square root of 5x over the square root of x squared. Okay, so x squared, that's kind of different. Notice I have 2 x's here, and I can pull those out. I have a group of x's. I probably didn't even need to do that here. So my final answer is the square root of 5x over x. I no longer have a radical in my denominator, so this is the valid answer. All right. Let's look at example 7. Okay, I'm noticing here that I can simplify this fraction before I start to factor it out. Okay, so that's what I'm going to do. I know that 18 and 6 are both divisible by 3, right? 3 times 6 is 18. Oh, hold on a second. 18 divided by 6 is 3. I don't need to do anything with that. It's just the square root of 3. Okay, we're done. All right. Well, that was easy. Let's go to practice number 7. Okay, so the only thing that I could factor out of these would be the, or simplify these would be the x's, okay? But I'm gonna leave them in there for now. So I need to go ahead and rationalize my denominator, or my, my denominator. Okay, so we have the square root of 16x squared, and we have the square root of 9x. Okay. Now you might notice here that these are perfect squares. So we can actually factor before we rationalize the denominator. So I'm going to do that. I know that 16 factors out to 4 times 4, and then you have x and x, right? So that would be your square root. So I would be able to pull out a 4 and an x from here, leaving nothing else. So I end up with 4x. With 9, though, I can factor out a 3 right here. But I can't factor out that x. That x is going to have to stay. So I have 3 square root of x, of an x. All right. So now that I've factored them out, so I couldn't simplify, but I could factor. So I factored. And now I need to rationalize my denominator. I need to get rid of that square root. So when you have a coefficient in front of the square root, you don't have to multiply by the whole thing. You only multiply by what is inside of the square root, okay? So in this case, I am going to multiply by x, the square root of x on both of those. And I end up with the square root, 4x square root of x. So 4x times the square root of x. And then I have 3 times the square root of x. Really, this is x squared, but x times x. Now I can pull this out right here. These two pair up. And I can rewrite this as, and I'm going to come down here, 4x square root of x over 3x. Okay. Now, you know how up here I said we could simplify this by getting rid of those x's? We could have done that there, and then that would have eliminated this last step. But I wanted you to see that when we get to this point, even though we cannot simplify our 4/3, we can simplify our x's. Remember, x over x is the same as 1, right? So they cancel each other out. It'd be like x to the first power minus the first power gives you x to the 0, okay, which gives you just 1, okay? So our final answer here is 4 square root of x over 3. All right. Example number 8. Okay. This fraction can't be simplified. However, my 8n can be factored. So we're going to factor that out. So let's do the square root of 7 over the square root of 8n. Okay, when I factor out 8, okay, I end up with 2 times 2 times 2, and we can't forget this n. And so when I'm going to circle my pairs. So I have a group of 2 that's going to be factored out and 2n left inside. Okay. All right. So normally we would be done here, but remember we cannot have a radical in the denominator. So now we have to rationalize the denominator. So what that means is I'm going to multiply by the square root of 2n on both of these. And remember, we don't have to multiply the 2 also, just the radical. So we end up with, I'm going to go ahead and just multiply those out here, 14n on the top, and so 2 square root of 2 times 2 is 4, n times n is n squared. Okay. All right, so 14, when I factor out 14, I only get 2 times 7. So there's no pairs. I can't really factor that numerator out any further. My 4n squared, though, I can. So 4n squared gives me 2 times 2, which is the 4, and then n times n, which is my n squared. And when I factor that out, I'm left with 2n. Some of you may be seeing the pattern that when you rationalize the denominator, it's basically the number without the square root once you multiply everything by that. And that is the case. So we are going to take 2n here and multiply it by this 2, and we get 4n. So we have the square root of 14n over 4n. Okay. Now, a lot of you may want to simplify this, but you can't. And the reason you can't is because you're not, it is not proper to simplify a radical and then a coefficient and variable. If 14n was outside of the radical, then yes, you could simplify the 14n and the 4n. But because it's inside of the radical, you cannot simplify it, okay? You can simplify a radical and a radical, and you can simplify a coefficient and coefficient, and you can simplify a variable and a variable, okay? But you can't simplify what's under a radical to what's not under a radical. So this is your answer for example 8. Okay, let's look at practice 8. Practice 8 is similar to a combination of what we've just done if you want to try it on your own. I am actually going to simplify the whole thing out before I start factoring or trying to rationalize the denominator. So I'm going to simplify 20 over 16, and then I'm going to simplify my x over x cubed. Okay. So I have Oops. Okay, so what this becomes is the square root of 5 over 4x squared. Okay, and then of course I would write it like this, 5 over 4x squared. Now, right now you'd be saying maybe I need to rationalize the denominator, and that is true. We can't have a radical, but 4x squared is a perfect square. Remember, we did it up here somewhere. So 4 factors out to 2 times 2x squared factors out to x times x. They both pair up. So really, you end up with the square root of 5 over 2x, 2 times x. And that's your final answer right here. Okay, let's go down to example 9. Okay, so again, I am going to simplify my two radicals. So I have 72 over 20. Now I know, I think they're both divisible by 4. Let's see. Yep. So divide them both by 4, and you end up with 18 over 5, okay? And then x to the 4th minus the 3rd is just x, so it's going to be 18x, okay? So this would be the square root of 18x over 3 square root 5. It makes it a lot easier to rationalize the denominator after you've simplified, because otherwise we'd be having to multiply 72x to the 4th times 20x to the 3rd. That would give us way too large of a number. As it stands right now, we only have to multiply by the square root of 5. But before I do that, I do want to factor out my 18x. So 18 gives us 2, 9, and 3, 3. Okay, so I end up with 2 times 3 times 3 times x. And I can factor out a 3. So I end up with 3 square root of 2x. Okay. 3 square root of 2x over 3 square root of 5. And now I'm going to, I could simplify my 3's and get rid of those. So we can do that. And then I'm going to rationalize the denominator and multiply both the top and the bottom by the square root of 5. So I end up with the square root of 10x over the square root of 25. And that will simplify out to the square root of 10x over 5. And again, you can't simplify that because the 10x is under the radical and the 5 is not. Okay. All right. So let's move on to practice number 9. Okay, you could try this one on your own to see, because it's very similar to example 9. This 25 is a perfect square, so I'm going to pull that out. Okay, and then our 10 and 14 can simplify. And there you have it. Okay, so there was a lot of simplifying and rationalizing the denominator. That was what was new in this lesson. So if you have any questions, let me know. And I will see you all at our next Zoom. Bye-bye.